Okay, so, sorry. I'll just zoom in a bit. I can't. Okay, so question 7, the train starts from rest. So what that tells us is that that's your initial condition. Okay, so if it starts from rest, that means that at starting is time 0 and rest means it's not moving. So that means, sorry, I'm not presenting my screen. Hang on, sorry, I forgot to do that. Remember all these things. Okay, can you see the book now? Is that okay? So start from rest means that velocity of 0 is equal to 0, okay? And it also means that S of 0 equals 0. Does that make sense? Okay, so start from rest means the distance when time is 0 is equal to 0 and the speed when time is 0 is equal to 0. 2.5 minutes later means that t, now this is in minutes, if you look at everything else is per second. So you'd want to change that to seconds. So 2.5 minutes is 2.5 by 60 is 150 seconds, okay? And then you're given the velocity here. There's your velocity, okay? So find an expression for the distance. And we know distance is the integral of velocity. So you want to integrate that and then find the distance between the two stations. Well, the distance of station A will be 0 and B. So do you want me to go through it? Or do you think you can manage it?
Could you go through it, please?
Okay, so you're just going to, hang on, get the camera going. Now, I was having a few issues with the camera. Let's just see. Let me see if I can delete some of the videos and see if that helps. All you have to do is, Cordy, what do you need to do to get from velocity to distance?
Is it integrate?
Yeah. Okay, so you're just going to integrate that. And then you're going to get a C when you integrate it. And to find out C, you just, sorry, the camera's not going. I'll have to write it down the word. So hopefully this thing will work. Bear with me.
Ooh.
Right, Jamboard. Start a new Jamboard. Share. Okay, have you guys seen this before, this whiteboard thing?
No.
Okay, so it's basically an interactive whiteboard on the computer, and I can write on it. I can give you access to write on it as well. But for now, so if I'm writing on it and I want to be able to see the book as well, so I'm just going to move it over here. Open up the book. That over here. So we know that, and I'm just going to type because it's easier than trying to do maths equations. So I know v of 0 is equal to 0, okay, because that's my initial condition. V of 0 is equal to 0. And I also know that the distance at time 0, that's how I start my problem, okay? I also know that v is equal to 0.6 times t minus 0.004 squared. I'm just going to write T2 there. I'm not going to bother with trying to find out how to square it. Okay, so if I want to get the distance, I have to integrate that. All right. So I'm going to write S is equal to the integral of v dt. Okay, that's the integral of 0.6t here, minus 0.004t squared. Okay, dt. So when I integrate 0.6t, what am I going to get, Gordian?
60 squared over 2.
Yeah. So that's going to be 0.3t squared. So I'm just dividing. Sorry, points don't come out very well in this. Okay. Then that's 0.004. That's going to be over 3. So minus 0.004 over 3 times t cubed plus c. Okay.
Mm-hmm.
And we know up here that s of 0 is equal to 0. So if I put in 0 here is equal to 0 minus 0 plus c. So that means c is equal to 0. Okay.
Mm-hmm.
So that's part 1 done. It's 0.3t squared minus whatever that is, t cubed plus c, and c is gone, okay, because we know it's equal to 0. And the second part is find the distance between the two stations. The first station is at t0, so so you're going to find SA and SB, and you're going to, the distance between them is SB minus SA. Does that make sense?
Yep.
And we know A is when t is equal to 0, so you just put in 0 there, and that gives you SA, which is 0. SB is when t is equal to 2.5 minutes, which is 150 seconds. So you put 150 in for t here and here, and that gives you SB. And that's all you have to do. Does that make sense?
Yeah.
Good. Okay. I'm going to close that. Anybody, any other questions? Would you rather do some more work on this, or do you want to look at the algebra?
Look at the algebra.
Yeah.
Right. Okay, so I'm going to open those up on Classroom. Just give me a second. It's your maths. The algebra is here. Okay. And here's our questions. So any particular questions that we want to go through?
I'll jump.
Part 2 of question 1.
Part 2 of question 1. Okay, so part 1 is just a quadratic equation. Was it factorizable, or did you have to use the formula?
No, I think it was factorizable.
It was factorizable. Okay, so let's, I'm just going to move on to another one here. So you have, so it's 2x. I don't like these x's, but they're easier to draw with here on the screen. 15, so 5 and 3 won't work. 3 and 5 won't work. 50 and 1 won't work. You sure it was factorizable? What were the factors?
3 and 2/5.
Oh, yeah. Yeah, sorry. 2 3s is 6 and then 5. Okay, so 2x minus 5, x minus 3. So that means x is equal to 5 over 2, or x is equal to 3. Is that okay for everyone? That gives you 2. So FOIL 2x by x gives the 2x squared. 2x by minus 3 is minus 6x minus 5x. That's your minus 11x. And then minus 5 by minus 3 is plus 15. And that's your 2 possible values for x. Okay? Now, when it says hence, that means, is everybody able to see this okay? Hence means use what you just did. And even though it says otherwise, hence is usually the easiest way to do it. Now, what do you notice about this equation compared to the equation in part 1? Anyone? And you see,
Its x's are equal to 1 over t squared.
exactly. See, it's the exact same question, except they've changed. It's a 2, it's a minus 11, it's plus 15. X is equal to 1 over t squared. Oh, sorry, I need to go back. Okay. And that's exactly what you do. So, you know, this is your first value for x, or we do the 3 first, that would be a bit easier. So we're basically saying 1 over t squared is equal to 3. So that means t squared, I'm just going to flip each side, is equal to 1 over 3. Does that make sense? Everyone following me okay? Shout if you're stuck or if you just want me to slow down or go back over anything. And then we just get the square root of both sides then. T is equal to 1 over the square root of 3. Okay? And then we do the exact same for the other one. So x is 5 over 2. I'm just going to erase the original bit here. Sorry, this is a bit messy. I'm only getting used to using this thing here, so bear with me. So basically now I know 1 over t squared is equal to 5 over 2. So I've got 1 over t squared is equal to 5 over 2. So if I flip both sides of that, I get t squared is equal to 2 over 5. And then I just get the square root of both sides. T is equal to the square root of 2 over 5. And that is 25 marks in less than 5 minutes. Okay. Hence, all right, hence is a very important thing. And when they say hence, you basically want to say, what's the connection between what I just did and what they're asking me to do now? Okay, does that make sense?
Yep.
All right. Any other particular ones, or we just move on one at a time?
The next one was grand. It was the one after that where I had the root 3x.
Okay, so the next one is the cubic equation. One integer root. You just have to find the first root by trial and error, and then you divide, you do your long division to get a quadratic, and then you solve the quadratic, okay? So that should be fairly straightforward. So this one here, was it?
Yeah, I thought you could just square everything, but I was wrong. So
it's a little bit awkward because you actually have to square it twice because there's what we call these surds.
yeah.
We did, I think this was chapter 2. So you're going to have to square it and then square it again. So let me go on to a new page here. Okay, and move it up a bit. Actually, do you know what we yeah, so what you do is, so let me just write it down. You've got 3x minus 5. And minus 3 is equal to root x minus 6. So when you're squaring it, you're basically saying, I'm squaring this whole side, and I'm squaring this whole side. So the right is easy because you've just got one thing. So the two, if you like, the square root and the squared cancel each other. Okay, so this is just going to end up, the right-hand side is just x minus 6. But on the right-hand side, we have to do FOIL. Okay, so you square this, you get 3x minus 5. Okay, sorry about the writing on this. Then we have 2 times the first by the last, so 2 3s is 6, so it'd be 6 times root 3x minus 5. And then plus 9. Does that make sense? And now you see this term here is the square root 1. That's the only square root left now. So if we bring that to one side and then everything else to the other side, and because it's minus, I'm going to move it to the right. And then I'm going to put these two to the left, okay? So I've got 3x here, minus this x is 2x. Is that okay? And then you have -5 plus 9, that's 4. Bring the x over, that's 6, so that's 2x plus 10. And then this side, I've got 6 times the square root of 3x minus 5. Is that okay? And then you have to square it all over again. So you take this side, square it, and this side, square it. Okay? So if I square 2x, you've got 2 squared is 4, x squared is x squared. 2 times the first by the last is 2 by 10 is 20, 2 is 40x, and 10 squared is 100. Is that okay with everyone?
Yep.
And then on the right, now be very careful here. You have to remember to square the 6 and the other thing. So you've got the 6 squared is 36, and the other bit squared is just 3x minus 5 because the square and the square root cancel. Okay? And then you would multiply that out. So 36 by 3 is 90, 108 minus 180. Okay, and then you just have a normal quadratic, bring the two of those over and solve the quadratic, which I think you should be able to do yourselves. All right, so if you have 2 square roots and you have this extra little bit, sorry, where's it gone? This, but with something else here, you're actually going to have to end up squaring it twice, and you're going to have to use FOIL on one side, okay? So if I just go down and show you, is minus 8 plus 9, and that, so yeah, minus 6 times that, and then you just square that. So, and yeah, you get everything there, I'll divide by 4, so that'll make it simpler as well, okay? So their model solutions are kind of oversimplified. They skip a few steps between each line, but are you okay that you can handle it from there?
Yep.
Okay. Don't be shy to ask if you're not. Okay. Sorry. So simple equations, are you okay?
Yeah.
So the big thing is this one in the middle. I get rid of the fractions, and then once you get rid of the fractions, the only thing with these, like, they're slow because you have to go through it bit by bit. So you decide what you're going to eliminate, which I would think would be either Y or Z. They're just going to be, yeah, if you multiply this by 4, you'll have a plus Z, and that'll cancel that nicely, and then just times 4 again, cancel the other one. So that should be straightforward enough. What about the factorizing one? How do you
Yeah, no,
think?
that one was quite confusing. It was just because it was when like I had the 2 BAB. It was just quite difficult, I found.
The bit on the left?
Yeah, no, because like
Oh, when you were
there's a few
dividing that, it
examples
was
in the
just
book.
awkward.
Yeah, no, like there's a few examples in the book, but it would only be like x squared plus px. It wouldn't, or
Not two
plus
different
3.
letters, yeah. I wonder
Yeah,
was
so you'd
you
be
know
like doing
on
it
a
with
mock
the
paper or a real one?
like instead of the
Sure.
bx, you'd probably have the p. So that's
Yeah.
why it's kind of confusing.
Yeah, that was kind of because you had the P here and you had A and B here.
Yeah.
So they've done it. I don't like doing this method. I like doing it by the long division. I think it's just simpler than trying to set everything else out. Do you want me to go through it, or anyone
Yes,
want me
please.
to go through it? Yeah. Okay. So let's do these things. I'll say sorry about my handwriting in this, but it might improve. Where's the question? Okay. So basically, because it's a factor, the factor theorem says that if it's a factor, it'll divide in evenly. So I've got x squared. Actually, I might just try it with typing. No, I'm not. Okay. I've got x squared plus bx plus 3. And I want to divide it into ax cubed. Yeah, so you're going to have combinations of letters here. It's a bit of a nightmare. Just not going to be fun. Let's see if I can get the camera going again. Bear with me a sec. It'll be just easier to write. Sorry, lads. Okay, so x cubed plus bx squared plus 11x plus So x squared into x cubed just goes ax squared times. That's straightforward enough. And then we multiply back. So you've got the ax cubed. And make sure you line x cubed under x cubed, etc. Okay. Then we have a by p. So that's plus ap. So when you're doing, you know, our SNL, signs, numbers, letters, when you're doing the letters, do them in alphabetical order, but with x last. So that's going to be AP x cubed, okay? Because you've got a by p and then x squared, sorry. X squared, sorry, I should have had an x back at the very beginning. Sorry, that should just be x there. Okay, and this is x squared. Okay, and then we have a by 3, so that's 3a x. And now we're going to subtract. And these two will cancel, okay? Now I have b and basically what I'm going to do is change my sign. So this becomes a minus and this becomes a minus, okay? And then you've got b, so it's x squared times b minus ap, okay? And that's times x squared. And then you've plus 11 minus 3a times x plus or, okay? And then when you divide it in again, we have plus b minus ap, okay? And I'm just going to put that in brackets. So you're going to have b minus ap times x squared plus p times b minus ap times x plus 3 times b minus ap. Okay, sorry, that's a bit messy there. This will cancel again, okay? And again, change your signs. This will be minus and this will be minus, okay? Everybody with me so far?
Yeah.
So for the x's, I've got 11 minus 3a minus pb, or actually it's minus p times b minus ap. That's all times x, okay? And that's basically, if you look at this, because there has to be no remainder, the coefficient of x has to be 0, okay? That makes sense? Okay, and that's, if you look, that's the over here. So the,
Why didn't you use the or?
I haven't got to that yet. That's the second part. Okay. So,
so that you just
the x's, it's like with the complex numbers that the real has to equal the real, the imaginary has to equal the imaginary. The x's have to get to 0. The number term has to get to 0. So this is part 1. 11 minus 3a has to equal p times b minus ap. And then if we take the number part, which is here, you have, let's go back to the black. You have R minus, what's that? 3 times, R minus 3 times BP, sorry, B minus AP, sorry. Okay, that has to equal 0 as well, okay? That makes sense? Now, the problem here, when we look at that, if we look over here, B is gone. See that? So we have P times R. I'm trying to see, how do we get to that one? B, okay, so using this first one, yeah. If we use part 1, that gives us, what are we doing? B minus AP. See the B minus AP here, okay? So we have B minus AP is 11 minus 3A, okay? So this one tells us that B minus AP is equal to 11 minus 3A over P. That makes sense? So just rearranging part 1. Sorry, I'm kind of running out of space here. This bit here, okay? We know that's equal to 0, and that gave us this here. So looking at that, see the B minus AP, I want to get rid of this. So I can use this equation, and then I can put this in to here. You following me? Yeah.
Yeah.
So let me just, I'm going to get rid of this up here so we can just use the top half. Okay. I'll let you do everything else bigger, but not the rubber. Right, so I'll go back to the pen. So I know that B minus AP from part 1, I know that B minus AP is equal to 11 minus 3A all over P. So I changed that second part then to R minus 3 times 11 minus 3A over P is equal to 0, because the number remainder of the division has to be 0. Get rid of my fractions. So I multiply everything by P. So I'm multiplying this by P and this by P. So here you've got RP or PR, and the P's cancel here. We've got minus 3 times 11, which is 33, plus 3 3's is 9, so plus 9A. And then if you bring them over, that's equal to 0. So then PR is equal to 33 minus 9A, and that's your answer. Okay. So with the long division, you just have to take it nice and slow and line up your x's, your x squareds, your x cubed. And just remember, if it's a factor, it divides in evenly, and that means the remainder is 0. And that's how we were able to work out the first bit and the second bit. It's using, because one remainder was the x part and one remainder was a number part. So they both had to be equal to 0 separately. Okay. So that's that one. Any other ones you want me? This is the binomial expansion. Well, actually, that's not binomial expansion. It's just a multiplying out. So with this one, you just multiply it out, and then you find what's the coefficient of x and the coefficient of x squared, and let them be equal to each other, and you'd be able to figure out P.
They kind of had the same question on was it 2018 question B. It was kind of the same long revision.
Find the coefficient given. Yes, exactly. So that's it. So maybe try that one. Do you want to try that one yourselves now? Okay, that's the same idea. Okay, so do the long division, get the remainders, let them equal to 0, and you should be able to work those out. Okay, and while you're doing that, I'm just going to see, well, we're nearly finished anyway, but I'm just going to see if I can get this camera thing working.
Miss, can I just ask you a question?
Of course.
When it comes to binomial expansions, what does it actually mean by the coefficients of a term independent of x in the expansion? Because
so when you multiply, so say you're doing, hang on, let me just pull up one of the examples there. So the one above, sorry, Jim. Like this one here.
Yeah.
Basically, you're going to start out with an x to the power of 8, and then the x term is going to keep going up, and the 1 over going down, and the 1 over x is coming up. So eventually, at one stage, because it's the power of 8, by the time the x gets to the power of 4, the 1 over x will be at the power. It'll be 1 over x to the power of 4. So the x's will cancel out, and you'll be independent of x means there's no x. So your very first one will be x to the power of 8. The next one will be x to the power of 7 times 1 over x, which is x to the power of 6. The next one will be x to the power of 4, then x squared, and then you have one that's just a number. And then it'll go to 1 over x squared, 1 over x to the 4, etc. Does that make sense? Do you want me to run through it quickly?
Yeah, it's just, I was kind of confused because it wasn't easy.
Yeah, it only happens, so you've got x plus 1 over x, the power of 8, okay? So your first term is just going to be x to the power of 8. Your next term is going to be 8c1, which is just 8 really, okay? Times, this is going down by 1, so that'll be x to the power of 7. And then this will be 1 over x, and the x has started to come into it, okay? The next one would be 8c2, and you'll have x gone down to 6, and 1 over x gone up to 2, okay? Is that making sense so far? Then you'll have x8c3, the x has gone down to 5 now, and the 1 over x has gone up to 3. And then the next one, which is the one we're looking for, so you don't even have to go all the way along here. You don't have to do all 9 terms. X to the power of 4 times 1 over x to the power of 4, okay? So when you go back, if you multiply this by this, you get x to the power of 6. If you multiply this by this, you get x to the power of 4. This by this is x squared, and this by this is just 1. So this term is going to be independent of x because the x's cancel out. See that? That makes sense?
Yeah.
And then you just put that into your calculator, 8 choose 4, and whatever that literally that's the button under the AC button. It's NCR, so I do 8 NCR 4, and it's 70, and that's your answer. So in all of these, this bit is a number, and then this is like x or y or whatever it happens to be. But because there's an x and then there's a 1 over x, at some point they're going to cancel out, and that's your independent term. So it'll only happen when you have an x and then a fraction x.
Okay. Yeah, I see what you mean now. I was just kind of confused.
Yeah.
By the wording they use because I'm not used to questions.
Yeah. And that, that's why we want to try and look at as many questions as we can, so you get used to the kind of things, the way they put things, and just get used to the terminology.
Yeah.
Okay,
Yeah.
we look at that. So try that one. Try both of those actually. Why don't you all try that binomial one and the factorizing one? Okay. So that's 2018 question 2 on that set and question 2. So it's the whole of 2018 question 2. Okay. So if everybody tries that and have, you know, if you've the more of the other ones you can do, the better. It's all practice for you. Okay.
Okay.
That's
Thanks,
it.
miss.
So, all right. See you tomorrow. lads.
Do we send in 2018 question 2?
Yes, please.
All right, Grant.
Okay, and then whatever from this morning as well. They shouldn't take too long.
Thanks, miss.
Okie doke. See ya.
Thank you, miss.
Thank you,
Bye.
miss.
Right. Bye.
Thanks, miss.